Section 8.2, Trigonometric Form for complex numbers. We are going to learn how to write a given complex number from standard form into trigonometric form. And we're going to see why we need those later on, why we need to learn the trigonometric form. But in order for us to get to that point, we need first to learn some basic foundations about that. First, we're going to introduce the complex plane. It's the same as the xy plane before, but just instead of saying x-axis, y-axis, we're going to say this is the real axis, this is the imaginary axis. So we're going to use them to plot complex numbers or to graph complex numbers. So how to graph a complex number? We can say by definition the graph of a complex number x plus iy or yi is basically a vector. It's like an arrow that extends from the origin to xy, to point xy in the complex plane. So let's say we are asked, someone asked us to graph, let's say z equals 3 plus 2i. Z equals 3 plus 2i. Think about it this way. This is the x, this is the y, x and y. So this is 3 comma 2. Think about it that way, as a point, 3 comma 2. So when you plot the 3 comma 2 on the x, on the complex plane, so 1, 2, 3, and then 2, 3, 2. So then the vector from O to there is this one. So this is the complex number, 3 plus 2i. 3 plus 2i. We can look at a different example. Let's say just negative I. Negative I, this means is 0 plus negative I. So it's or 0 minus I. So this is equivalent to 0 comma negative 1. So if I want to put the point on the graph, 0 comma negative 1 is here. So it would go like this. This is z equals negative I. We can plot more. Let's say negative 3 minus I. So again, we do it the same way. Negative 3 to the left and 1 down. This is the complex number, z equals negative 3 minus I. So that's how we plot the complex numbers in the complex plane. Now, two things we're going to introduce here. One called the modulus and one called the argument. Modulus is basically the length of that complex number. So the length of the complex number. But this is just the complex language, complex number language. We call it modulus. So here in xy plane before, from like algebra, we called it the length of the segment. In vectors we called it magnitude. Here we call it modulus or absolute value. So we say the modulus or absolute value of the complex number z equals x plus iy is basically its distance from the origin. So is the distance from the origin to point xy. So if I want to put it somewhere in the xy plane, a random point here, this is the complex number z equals x plus iy or yi. So the magnitude or the modulus of this, if you drop a height, this is x, this is y. So we can find the modulus or the absolute value of this using In this right triangle, the Pythagorean theorem, the square root of x squared plus y squared. That's called the modulus of a complex number. Example, let's say z equals -3 plus 4i. We would like to find the absolute value of z. So the absolute value of z is the square root of the first number, x. Although it's negative, we square all of it. And 4, no I. As you can see, no I. So that gives us 9 plus 16. That's the square root of 25, which is in return 5. That's the modulus of a complex number. What about if z equals 7i? There's no x. This means it's 0 plus 7i. So the modulus of z is the square root of 0 squared plus 7 squared. That equals 49. And the answer is 7. That's the modulus. Now the argument of a complex number z equals x plus iy is what? Is defined as the smallest positive angle, call it theta, from the positive x, not x-axis, here we're talking about real axis, to the graph of z. So let's say we have a complex number here, z equals x plus yi, drop by height. As you know, this is x, y, that's the modulus of z. This is theta. So several things we can get out of this. First thing, I can find cosine theta is the adjacent over the hypotenuse. I'm gonna call this r instead of keep writing opposite value. And from here, cross multiply r cosine theta is x. Sine theta is y over r. So y equals r sine theta. So we get x and y. And usually when we would like to find theta, most of the time we use tangent. So tangent theta is the opposite over adjacent because x and y will be given. So theta from here is tan inverse of y over x. That's the argument. And a lot of times we write it like this. This is the arg of z, the argument of z. That's the argument of z. So now from these two, look what we're gonna do. We are going to we know z is x plus yi. Okay, so we found x earlier. It's r cosine theta, so r cosine theta. And y is r sine theta, I. What we can do, we can factor r out. That will give us cosine theta plus I sine theta. This is called the trigonometric form. Trigonometric form of a complex number. That's called the trigonometric form of a complex number. Note, some people abbreviate this as z equals, you take the r, the first letter, so that gives us RCIS theta. So these mean the same thing. That's just an abbreviation. So let's look at an example. If they ask us, right, let's say z equals 1 plus I root 3 in trigonometric form. So I'm going to call trig form in trigonometric form. So how do we write that out? If you look at the box formula, we need two things, r and theta. R is always easier to find. R, remember, was the absolute value of z, the square root of 1 square plus square root of 3 square. So then r equals 1 plus 3. R equals 2. That's r. Now to find theta, I give you the formula area, tan inverse y over x. Tan inverse, y is the square root of 3 over 1. Tan inverse of square root of 3. That's what theta is. Now what is the angle is tangent is square root of 3. This is really pi over 3, 60-degree angle. 60 degree. Now you need to be careful here. You need to be careful. Because there's more than one angle that its tangent is the square root of 3. So what you always do, that's why we learn how to graph complex numbers. Always graph the given z. 1, 1, and the square root of 3, somewhere here. And make sure that it makes sense to you that the angle you found, which is pi over 3, does that make sense? It is really pi over 3? Yes, it is. It's really right there. So now I found this is theta. R was 2, theta, we found it pi over 3. So z equals R cosine theta plus I sine theta. When you start working on this, write it down so this way you don't forget it. So z equals R is 2 cosine pi over 3 plus I sine pi over 3. This is the answer, or you can write it's 2 cis theta, which is pi over 3. That's the complex form, trigonometric form of a complex number. Trigonometric form of a complex number. So students ask, can I put that 60 degrees? Doesn't have to be in radians. Yes, it can be 60 degrees. That's totally fine. It doesn't have to be always in radians. Let's look at another example. Same for z equals 1 minus I. 1 minus I. So what we need to do is find the modulus of z, which is r, the square root of 1 square plus negative 1 square. That gives us the square root of 1 plus 1, which is the square root of 2. So it doesn't always have to end up to be simplified like so. So that's z. Now we need theta. Theta is tan inverse y over x. Tan inverse of negative 1. Tan inverse of negative 1. So this is how I do it. Think about that. If there's no negative sign, that would be 45-degree angle. But we need to graph the given complex number, 1 minus I. 1 minus I. So this is 1 and this is minus 1. So it's here. So the smallest positive angle with the positive real axis is this one. That's theta. See how large it is? That's the first angle. So if that one is 45, this should be negative 45 there. So theta would be 360 subtract 45, which is 315 degrees. And I'm going to keep it in degrees here, 315. So now I got r and theta. So then z equals r is the square root of 2 cosine 315 plus I sine 315. That's all we need to do. So plotting the graph or graphing the complex number given one, it's very important. Okay, it's really very important. The other way, maybe they can ask us to, what about if they ask us write something like 4 plus the square root of negative 36 in trig form. So first thing I'm going to say, let that be z. Z equals 4 plus. We take the negative outside as an I and the 36 as 6. So that's basically 4 plus 6i. 4 plus 6i. I want to find r. R is the square root of 4 square plus 6 square. That gives us 16 plus 36, which simplifies to 52. But 52, it's 4 times 13. It's important to simplify it like so. So r equals 2 square root of 13. We got r. Now we need to find theta. So theta is tangent inverse of y over x. So theta is tangent inverse of 3 over 2. We don't know how to do this. It's not something we are familiar with that we can find so easily. So that's why we have to use a calculator to find this out. So if you put that in the calculator, making sure it's the mode is degrees, this will give us about 56.3 degrees. That's the theta. That's theta. So now we need to also be careful. You need to plot this z 4 plus 6. So 4 here and 6 there. So that gives us this one. This is theta. This is theta. Does it make sense? It's about 56. Yes, it does make sense. So we're okay. So then the complex number z equals r cosine theta that we just found plus I sine theta. Okay, keep in mind, don't put this in the calculator again. If you try to put cosine this in the calculator and then sine 56.3 and multiply the result by 2 square root of 13, you will go back to the standard form, to the original problem that they gave us. You can use it to check the answer if you like, but that's the form that the final answer should be in trigonometric form, like so. They can go backwards, so they can ask us, write, let's say z equals 4 cis 30 degrees in standard form. Some people call it rectangular form. So how do we do this? Well, 4, this means cosine 30 plus I sine 30. Z equals 4. This is the square root of 3 over 2 plus I times 1/2. Then z equals, multiply the 4 in, 2 square root of 3 plus 2i. This is the standard form. Or, as I said, some people call it the rectangular form. So that's what we have here. So sometimes they give it to you to write in standard form either in degrees or radians. So either way, it doesn't matter how is it given to us. And why are we learning how to convert this? Because this will help us in the next section how to apply this to make the calculations easier for us. We don't need this, but sometimes we have what we call exponential trigonometric form for complex number that was found by Euler. That looks like a little bit almost the same as this, but they write it differently, re to the I theta in this form, I sine theta, but we don't need this for now, or I cas theta. This is called exponential form of a complex number.